Hello team, welcome to Eastern Academy. On this session, we are going to discuss about number systems and part 5. So far we have discussed about how to handle binary numbers. But in this session, we are going to see some practical application where very easy when I'm handling something on decimal. But the same thing, how difficult it is becoming when I'm handling in binary. That's a trick. If that will be taking some time for you to understand the decimal and binary, but the principles of both are same. That's why I'm trying to explain on this session. Okay, so there are certain things that we remember. In decimal, we are always starting from 1. In binary, we are always starting from 0. Okay, there's a big difference. And the smallest 3-digit number is 100, but whereas the smallest 3-bit number is 000. So we always write. Also, we represent the binary in a short form. We call that as a hexadecimal, but it's nothing. It's a see. The problem with us is not to practice. We are going to live with this world. Are you going to spend 100 days and then you're going to practice? And every day you spend 1 minute. 100 days into 1 minute is 100 minutes. And spend 100 minutes on first day and master it. So I feel that the second one is right. Quickly grasp the hexadecimal and do this faster. So let us start seeing a small application of the binary and the hexadecimal. Then you will understand how do we going to apply that on our digital system in microprocessor based designs and everything. Okay, so let's go back to the board. Okay, so let us start. I go to the school, I carry a notebook. That notebook could be 100 pages. 100-page notebook. That's a 100 pages notebook. So each page, we call it as a page 1 to page 100. Okay. There's a trick here. Okay. We call from 1 to 100. This is a single digit and this is a 3-digit. We represent this way. That is 100 pages. For us, 1, 10, 100, 1000, these are all in decimal. In binary, we have 1, 2, 4, 8. Am I right? So, it's the same thing if I have to write in binary, 100-page notebook. 1 means I told you in binary we start from 0 and end with, let us assume that we have about 16 pages. Assuming 16 pages. That means that we write 1, 1, 1, 1. So this means 15. This is actually a 15 decimal. So I can write 0 to 111, but that's not the way we write. We write 0, 0, 0. So there's a big difference. Here, first difference is we start with 1 and start with 0. Second is you write only 1 digit. Here we write 4-bit and 0, 0, 0 to 111. That is the way we write. Here, off of the page, the ends with 49. Sorry, 50. 1 to 50. And next to off is starting from 51 to 100. Here, the off ends with 0, 1, 1, 1 and 1, 0, 0, 0. This is 7. This is 8. This is 0. So 0 to 7 is the first off. And 8 to 15 is the second off. And we go slightly different now. That's another important aspect. If I have only 16 page, if I have to do, then I have to write more bits. To avoid that, generally what people do here is, we start representing in hexadecimal. Let us get into hexadecimal. How we do that? In decimal, 1, 10, 100, 1000. In binary, 1, 2, 4, 8. In the hexadecimal, 1, 16, 256, 40, 96. That is 1 into 16 is 16. 16 into 16 is 256. 256 into 16 is, here same thing. 1 into 10 is 10. 10 into 10 is 100. 100 into 100 is 100 into 10 is 1000. Same thing here. 1 into 2 is 2. 2 into 2 is binary, 4. 4 into 2 is 8. So here 10 decimal, 2 is a binary, and 16 is hexadecimal. So please understand. And this is too small number. So generally it's difficult to represent. So let us remove. Let us start representing in binary, decimal and hexadecimal. And here 100, the equivalent is 256. Okay. So let us do this. I have a notebook here, the same thing. I have 100 pages. But let us assume that in hexadecimal, okay, in hexadecimal, we have, instead of 100, we take 256, then easy for us. But here, when I say 100, I write 1 to 100. So my notebook will always start from page number 1. My notebook will always end with page number 100. Please understand this. This is a very, very critical information. The same way, in binary, the same 100 page, my page start from 0. My page end at 255. But we write 255 as F. That is, in binary, it is 111, 111. But it is in hexadecimal. And this start from 00. That means that 0000. That is, I'm using 8 bits. Here I'm using 3 digits. 1 to 100, 00 to FF. So if you could able to relate these two, then you won the game. You win the game. If you have a problem in this, then stop here. The off page here is 1 to 50, 51 to this. Here, the off page is 7F and 80. Okay. That is, how do I start here? How did I do this? Okay. Let me erase of decimal, which we know very clearly. Okay. I have a memory of 0, 0. That is binary, and 1, 1, 1, 1. Am I right? So this is in the hexadecimal 0, 0, and FF in decimal, it is 0, 255. So I can represent anyway. For you to understand, I write 0 to 255 because humans use decimal. The short form of binary is 0, 0 to FF. The actual representation is this. Now, I want to make off. Simple. Very simple. The first MSB, the MSB bit. This is LSB. This is MSB. The MSB, you make it as a 0 here and 1 here. All the thing above will be off. That's the trick. So 0111 to 1000. That is, this is 7F. That is 7F. And the other one is 80. This is FF. This is no change. I don't change the last one. I change only the beginning one. And this is 127. This is 128. Please try to understand this. When I divide them into off, I'm making it off very simple, by making a last bit. Now, see here. This is 128. This is 128. And the total is 256. So, the total is 256. I made them as a 128 by 128. So, when I have the other page, when I have the decimal, when I have the 100 page, I divide them into 50 and 50. Now I divide them into 128 and 128. You know one thing, how do you write in this one? Hexadecimal, it's 80. 128 means 80. Okay, that is, it's actually in binary 1000. That is off. That is 128. This is 128. That is. So that's why I told you the number system one, try to understand 1, 2, 4, 8, 16, 32, 64, 128. This is, if you don't understand this binary, it will be very difficult for you to understand how the microprocessor is going to talk to the outside world, because it's here. Let me stop. Let me stop here. The microprocessor which has 8 address lines. Assume, let us have 8 address lines. A0, A1, A2, A3, A4, A5, A6, A7. This is MSB. Always the biggest bit is MSB and A0 is LSB. Never forget this. Same way, it accepts data through D0, D1 up to D7. That is 8 bits. This is 8 bits. Let us assume now, right now 8, because 8 is easy to handle. So once you understand the 8 bits, then we can move to other ones. Okay, so here is a trick. That means that microprocessor gives address and it will accept data. So try to link with microprocessor class. Otherwise don't worry. It's only a 8-bit. To explain the 8-bit application, I've just given you a small example of I've taken microprocessor, because he is the one who drives the address. Now the microprocessor having 8-bit can give maximum is 00, minimum is 000, all ones. Okay, A02, A7. Okay, so it starts from 0, 0, 0, 0, and then it ends with 1, 1, 1, 1. Okay, so that means that the microprocessor talking to the memory is starting from 0, 0, 0 and ending with 1, 1, 1. Nothing more than that, because see, try to understand with these 8 bits, A0 to A7, using binary, whatever way you write, minimum will be this, maximum will be this. That is 0, 255. You cannot write any number. You cannot write any number which is bigger than 255 in 8 bits. It's not possible. Same way, you cannot write any number below 0 or using 8 bits. So that's why that is the meaning of this. Smallest and the biggest. So what I am trying to tell you here is, we always have a understanding of 1 to 100. Now we are starting from 0 to 255. The trick here is the number of wires increases from 1, 2 like that. Let us take a case. Let us assume now. We have, if I have only one wire from the microprocessor, let's call A, which is only one wire A. So this wire can be a 0 or 1 because it's binary. It can be 0 volt or 5 volt. When it is 0 volt, it represents 0. When it is 5 volt, it represents 1. That means that it can address 2 lines. How many lines? 2 lines. It can address only 2 lines, not more than that. If you have two wires, 2 pins in microprocessor, A0 and A1. A0 and A1. Now you have 0, 0, 0, 1, 1, 0, 1, 1. You have 4 combination. That is in a memory, I can have 0, 0, 0, 1, 1, 0, 1, 1. So I can have 4 lines on the memory. I can address. Same thing if I have a A2. Then I can have, if I have A2, A1, A0. 3 wires. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That's all. You cannot have more than this combination. So your memory will have only 3 wires. Now I'll have 8 lines. Starting from 0 to 7. Or you can write it as a, if you write it on binary, you write 0, 0, 0 to 1, 1, 1. That's it. Nothing more than that. But keep on writing, that is boring. So what we did was, we wrote in a very simple way. What we wrote is a single wire. A single wire. And put a slash and put 8. That means that 8 wires. That means that this is not a single wire. This is a group of 8 wires. A group of 8 wires. And this is LSB. This is MSB. So your data starts from here, 0, 0, 0, 0. That is 0. Then 0, 0, 0, 1. That is 1. 1, 0, 0, 0, 128. 1, 1, 1, 1, 1, 1, 1, 0. 254. 1, 1, 1, 1, 1, 1, 1, 1, 1, 255. Am I right? So how it varies from 0 to this number. So you have to be very clear this. So always try to write MSB on the left side and LSB on the right side. Start from 0, 0, 0 up to 1, 1, 1, 1. Now, let us assume that. Let us take it this way. Your teacher wanted a 80-page notebook. But she said one condition. The condition is my first 40-page should be white. The second 40-page, it should be blue. So, because you can use white for math and blue for science. So you can carry only one notebook, that is sufficient. Okay. Now you carry one notebook which has 40 page and 40 page. You want to carry only one notebook. So your teacher wants you to carry only one notebook, but she says first 40 pages has to be white and second 40 pages has to be blue. So you also went to all the shops. No shops have this. They say that, hey, we don't have a book of this combination. But they said that, sir, we have a 40 page of white and 40 page of blue. You take it and combine it. Okay, then you thought your father got an idea. Oh, fine, man, I'll buy 240 pages. So, bought 240 page. This is white and the other one is blue. Okay, now the manufacturer said that this page starts from 1 to 40 and this page starts from 1 to 40. Understand? When you buy a notebook, they have only 1 to 40 individually. So if I buy a separate notebook of blue, that page number is 1 to 40. The same thing, when I have a black one, I have 1 to 40. But I combine together. When I combine together, the page starts from 1 to 80. Am I right? It is 1 to 80. But when your teacher said go to 69th page, what you will do, you know that 69th page is blue 19th page. Because this ends at 40. It starts at 50. So actually 69 comes here. But that also has a 19th page on the individual. On the individual book is the 19th page. Sorry, 29th page. It's a mistake. 69. 51. Sorry. 41. No? Sorry, 41. So 29th page. So for you, this is 69 because it's combined. But individually, that is blue 29. So you can write like this. Am I right? I can write like this on combined notebook page 69 equal to blue book page 29. Am I right? So both are same. Now let us take in a different way. Okay, this is a quite easy one. Now let us take slightly complex. Your teacher told, no, I want a notebook of 160 page. 160 page of 4 colors. One is white. The other one is blue. The other one is green. The other one is red. Okay. So you have 4 notebooks now. Each one is how many pages? 40 pages. 1 to 40. And 1 to 40. And 1 to 40. And 1 to 40. Okay. But when we combined all of them, it starts from 1 to 160. Trick. This is 1 to 40. 41 to 80. 81 to 120. 121 to 160. Am I right? Now, you have this. Try to see this page. This is a very, very important. That is, I build a single notebook of 160 page. using 4. Okay. When I see, for me, sometimes you may not know all these things, all done by your school days. Your father could have done this. And for me, I got 160 page. But inside this. So you know that automatically, if it is 150 page, if anything above 121, it goes on red. Anything between 81 to 120, it lies on green. You know that anything between 41 to 80, it lies on blue. If anything 1 to 40, it lies on white. Am I right? So you understand this very thoroughly. You do it in the college, the school also. But the same thing, when I handle it, the same thing in binary. Okay. Let us see, how do you understand? Let us see now. Instead of 160, I make it as a 256, 0 to, and each one is 64 page, 1 to 64. Because 64 means what? 64 into 4 is 256. Okay. Now each one is 64. But we don't write like this. We always write in as a thing 0 to 63. 0 to 63. That's the first change. The first change is this. Each notebook is 0 to 63. So I write this. I erase this. We don't do that. So 0 to 63, 0 to 63, 0 to 63, 0 to 63. Then I convert this to binary. This means 0, 0, 0, 1, 1, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1. 0, 0, 0. Okay. So if I write, see here, 1, 1, 1, 1, 1 means 1, 2, 4, 8, 16, 32. So 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 63. So try to master the binary as a binary up to 1 to 8, not more than that. So this is actually starting from 0 to 255, or we can write as a 0, 0, 0 to 0, 0, 1, 1, 1, 1, 63. Then 64, 0, 1, 0, 0 to 0, 1, 1, 1, 1. Then 1, 0, 1, 0. I know that it will be confusing, but you have to learn the binary. I told you on the class itself. 1, 1. But if you see, if you notice here, one small thing you will find out. This is only 6-bit because this notebook is having only 64 page. But this is 156, 256. So this one is common. And this one is common. This one is common. This one is common. But what is not common? This is common between the first notebook, the 0, 0. And the 0, 1 is common for blue. And this 1, 1 is common for green. 1 0, and 1 1 is common on red. Okay, so this try to understand. Okay, that is what I'm trying to say. Try to understand this. What is not common? What is common? So if I have a 64 page, that is common everywhere. And what is not common is the first 2 bits. So you had a 6-bit and you extend it to 8 bits because you added by 4 combination. So 1, 2, 3, 4. 1 means this one is 0, 0, 0, 1, 1, 0, 1, 1. That you add it with this. So if you add the 2 prefix of this number, then you get the actual address. Okay. This is the way the binary works. I understand this will be confusing, but it's a very easy one. And you think it's too complex. That's why we refuse to accept this all simple. This is the binary world. Try to put your thought into it. That means that I have divided into 4 blocks, 0, 0, 0, 1, 1, 0, 1, 1 in binary. That is 0, 1, 2, 3. Then each one start from 0 to 63. That is 0, 0, 0 to 6 ones individually. Then when I make it combined together, I add that starting address and the block name and I get the address. I address the end address and the block name. So this is the starting. That means that if I write in hexadecimal, now you understand hexadecimal. That is this one. See here. 0, 0. 3 F. 4 0. 7 F. 8 0. B F. C 0. And FF. So in your case, previously what you wrote was 1, 40, 41, 80, 81, 120, 121, 160. Now the same thing I have written in this way. Am I right? So right now I divide everything equal. Let us understand how to understand this equally divide. Then we will understand the other ones. Let us not worry about that. First we will do this. Let us try to understand this equal division. Now let us make it. I will divide this. I will stop this. Now let us assume that how I do that. I have 8 notebooks. Now I have 8 notebooks of 32 pages. Same thing, but I do 8 notebooks. Eight notebooks. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. I have 8 notebooks. Each notebook's 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Am I right? 0, 0 to 1, 1, 1. That is 7. This is 5-bit only because 32. So you start from 0, 0, 0, 0, 0, end with 1, 1, 1, 1. Each notebook. I write like this way, then you'll understand. I told you this is a 32 page note, 32 page. 8 into 32. Because we use 8 notebooks. It's 256. That is same. So this is from 1 to 256 only. But as I told you that in binary, we don't write 1 to 256. We write from 0 to 255. That's the first change. And we write from other way. We write in binary 0, 0, 0, 0, 0, 0, 0. And 0, 0, 0, 1, 1, 1, 1, 1. This is 1, 1, 1, 1, 1, 1. What about this? So this is 8 zeros, 0. and 8 ones, 255. Now the trick here is, this is each one is how many page? 32 page. Since it's 32 page, 2 power 5 is 32. So we start from 0, 0, 0, 0, 0, end is 1, 1, 1. So if you buy an individual notebook, a 32 page notebook, the page start from 1, end with 32. End with? That we know very clearly. If you buy a 32 page notebook from a shop, the first page is 1, the last page is 32. But in binary, we always start from 0 to 31. Both are same. But instead of starting from 1 to 31, 32, we start from 0 to 31. The same thing I write binary. 0, 0, 0, 0. And 31 is only 5 bits enough. That means that 1, 2, 4, 8, 16. 1, 1, 1, 1, 1. So 16 plus 8 plus 4 plus 2 plus 1 equal to 31. Am I right? So this has to be understood by you. Okay. So each notebook, every notebook start from 0 and end with 1, 1, 1. This is only 5 bits only. So every notebook you should know start and end. Individually, every notebook is starting from 0, 0, 0. So if you go to shop and buy a notebook, you get only this. But now, the same notebook, when you come on this side, you have combined, I told you, this is how many bits? 5 bits. This is 3 bits. Add together, you get 8. So this 0 added here, and this 0 comes here. The end is 1, 1, 1. So the starting is 0. This is a start and end of first notebook. So this is 0 and this is 31. And next one is 0, 0, 1. Then 0, 0, 0. Okay, then the end is 1, 1, 1. That is 32, 63. Then this one is 0, 1, 0. Start is 0, 0, 0. End is, I don't change this. You see this? This is common for the entire block, entire book. The entire book, this is common. Then 1, 1, 1. Then this is 64. And this is 95. Okay. So that's the way it goes. So finally it goes to 1, 1, 1, 0, 0, 0. And then is 1, 1, 1. If I write it on hexadecimal, forget about this. I write on hexadecimal. You take 4, 4, 0, 0, 1 F, 2, 0, 3 F, 4, 0, 5 F. Same way, 6, 0, 7 F, 8, 0, 9 F, A, 0, AF, sorry, BF, C, 0, TF, E, 0, this is E0, E0, FF. See here, this is one notebook, this is another notebook, this is third notebook, fourth, fifth, sixth, seventh, eighth. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 8 notebooks. So try to see this. See, now I written 60 to 7F. This is hexadecimal. So there is I know that you always dealt with binary. There's a small confusion. Okay, so deal with this. But what I've tried to explain to you here is literally no difference between your decimal and this binary handling. The only thing is there. That's what I explained to you, that how I will divide a 256 page notebook into 8 notebooks of 32 page. Okay. So this, if I erase everything now. Now I erase everything. I erase everything. See that. You take any notebook. You tell me now. Let us handle everything in binary. Everything we handle in binary now. I have 8 notebooks. Am I right? Now every notebook start from 000 to 1111. That is what every notebook starting and ending. Okay, if this notebook starts at 000 11111. So that is 0 to 31. This notebook also start from 000 to 11111. That is 0 to 31, 32 page. Now we are going to see from here. Here it starts from 0 to 255. We are going to see from here. Now let's take any notebook. Let us take 3. 0, 1, 2, 3, 4, 5, 6, 7. In decimal, if you write, means 1, 2, 3, 4, 5, 6, 7, 8. Now I want to know that this third notebook, what is the starting address? What is the ending address? Okay, easy. How do you do that? 3 means 0, 1, 1. Because it's 0 to 7. We have 3 bits. So 0, 1, 1. So write that 0, 1, 1. What is the starting address? 0. So ending address is, what is a block name? 011. Ending address is 111. So you divide them into 2 groups. Okay, that is 6, 0, 7F. So by given any block, if I ask you to find the which is the fifth block, it's very simple. Fifth is 101. 101, write it. And starting will be always 000, 5 bits. Ending will be always 11111. So this you say A0 to BF. That is fifth block. So try to understand this. See, I could have explained to you so fast, but you can pause here on the video and try to understand this as much as time. But how fast you do that, that fast you can do wonders. Now I do other way. Now I'm asking you 9C. 9C. It is in which book? Which book? What line? What page? Which book? What page? Simple. 9C. You make it as a 9. 1001. That is 9. C is 1110. Take the first 3 bits. 100, that is 4. So this 9C belongs to this page. Then what is this address? 1, 2, 3, 4, 5. Sorry. 1, 2, 4, 8, 16. So 16 plus 8 plus 4 plus 2. How much? 24 plus 6, 32. Sorry. 24 plus 4, 28 plus 2, 30. 30. That is 30th page. That is, on the 4th notebook, 30th page is 9C. Let us take another one. Let's take 7-2. Where is it? Because nothing is here, but you are asking here 7-2. 7 is 0-1-1-1. 2 is 0-0-1-0. You take this one, that is 3. Page number 3. Okay. Then you do this. 32 plus 0 plus 0 plus how much? 2 plus 0. So 36, 34 page. 3 and 34. But first of all, it's you have to make sure that how do we do this, the whole formula. So we have to write 0, 0, 0. There's a block 1, 0. 0, 0, 1, 0, 0, 1, block 2. Then so this has to be written by you. So also please understand, when you write 86, this 86 does not mean decimal. It is a 86 hexadecimal. That's why I convert it to 1, 0, 0, 6 is 0, 1, 1, 0. Now this belongs to fourth block, and 4 plus 2, sixth page. So fourth book, sixth page is equal to 86. So try to understand this. This is a very, very important for our microprocessor and memory interface. And I've written here 0, 0, 0. This is 3FF. This is 402 7F. We write like this. This one is E02 FF. Now, what is this called? This is a very famous word in digital electronics called memory map. What I've written notebook is nothing but a memory. It is nothing but this notebook is nothing but a memory. And this each one is a separate memory chip. How do we connect all of them? That we will see in the microprocessor class. Okay. So whatever I discussed so far, try to recollect. That means that I have connected multiple notebooks into single notebook. Okay, that it's a very, very important on electronic designs. If you don't understand this, you'll understand how your software and the microprocessor controlling the controllers or devices, everything. This is very, very, very critical. What I have discussed today on this number system, given a comparison of your decimal and binary, is a very, very important. I could have given you, I could have told you in a very slightly easy manner, but I think so. But that you have to say that whether I have expressed in easy or difficult manner. But this is the most important. How much you understand, how quick you solve this problem, then do it so many times, and let's try to understand this. So with this will be very useful for our microprocessor and memory interface class. Okay, that application I've just given a hint here. Okay, that I may not explain in detail. That's why I have given this extra talk here. So always all this number system topic, we underestimate the number system. That's why I've given about this is the fifth one. I'll be giving more and more. The number system lectures we normally underestimate. We think that it's easy to know. It is not easy. It is how fast you do that. How fast you do that. That's a trick. So that will enable you to do wonders. So please do not underestimate the power of number system. Okay. We will see the next number system topics on our next part. Okay. So all the 5 parts what we discuss, make sure that you have a thorough understanding of this 5. If you don't, please let me know. Okay, thank you.